Have you ever wondered how the manufacturing industry is transforming with the advent of digital innovation? Well, today I want to learn more about the future of manufacturing with a visionary leader who is at the forefront of this revolution. His name is Bryan DeBois, and he is the Director of Industrial AI at RoviSys. And they're a company renowned for integrating AI solutions into the world of manufacturing. So in our conversation today, I want to explore how the market is evolving, what steps industry leaders should take to adapt to digital transformation and, yes, AI, and from starting a digital transformation journey to unlocking new possibilities with AI, I'm going to ask Bryan to share his insights for any medium to large manufacturing company. Reaching listeners in 165 countries every day is testament to the unwavering support of you, my listeners, and our sponsors, without whom this podcast just simply wouldn't be possible. And it also gives me a chance to talk about the fact that legacy DRM failed to securely enable external collaboration, especially on sensitive files, and how every organisation faces this risk-trust contradiction where they can share content with untrusted third parties, yet expected to protect that data. So it's time for something more modern, a DRM solution that solves that dilemma without compromising security or productivity. And you can do all that with a company called Kiteworks that will enable you to say goodbye to deployment headaches, file transfer risk, collaboration barriers, and productivity constraints, so you can experience a more modern way to collaborate on sensitive content without sacrificing control or security. Please visit kiteworks.com to get started today. That's kiteworks.com to get started today. Now is the moment you've really been waiting for. It's time to get today's guest on. So buckle up and hold on tight as I beam your ears all the way to Wyoming, where Bryan is waiting to join us today. And we're going to talk about all this and uncover the exciting advancements and opportunities in manufacturing. So if you're ready to embrace the future of technology and manufacturing, you're going to love this one. So a massive warm welcome to the show. Can you tell everyone listening a little about who you are and what you do?
Yeah, great to be here, Neil. So I am Bryan DeBois. I am the Director of Industrial AI for a company called RoviSys. And RoviSys, what we do is we are a system integrator. And we can talk a little bit more about that in a minute and kind of what that means. But we really work primarily with manufacturing and industrial customers. And we've been around since 1989. And when you look at the world of manufacturing, there is typically a lot of very legacy equipment, very old equipment. This equipment, oftentimes these assets are a couple decades old at least. And so in that world, you have these companies called system integrators. And so they're going to take all of that equipment. They're going to take all of the different disparate technology from a lot of different vendors. And as a system integrator, we're going to put that together into a solution that solves a problem for that manufacturer. So that's kind of what RoviSys does. I've been with RoviSys for 24 years now. And 5 years ago, I was fortunate enough to be named director of this new division, Industrial AI. And really what we were doing with that is taking what we've always done, which is bring solutions to manufacturers, but now extend it into that artificial intelligence space. And I will be talking, I'm sure, a lot about that today in this episode, but kind of at a high level, it involves both AI, ML, as you would imagine, but then there's a lot that we do in my division around data infrastructure as well, because as you know, these AI algorithms are hungry for data. So we have to do a lot of kind of data infrastructure type of work to get to that AI future that all of our customers are trying to get to.
I love that. And that's one of the reasons I invited you on the podcast, because I always try and get people thinking differently about technologies like AI, the kind of areas that it's transforming at the moment, because it's very often areas you don't associate with technology. And before we started recording today, you were telling me in Wyoming, giving a digital transformation talk there.
That's right.
But largely the mining industry. So I'm curious, in what ways have you seen AI redefine digital transformation, specifically within that manufacturing industry that we're talking about here?
Yeah, it's been really interesting. And I'm not going to tell you that it's widespread adoption by any means yet, right? So, yeah. But I will say that every company that I talk to is interested, is either dipping their toe in today or is considering it, for the near future. The impact that it's having, though, and we'll talk a little bit more about some of the specific types of AI that RoviSys is working with, but the impact that we're having is we're now able to move some of these metrics that that have really not moved for a long time. So some of these processes that we're talking about, if you look at the glass industry, if you look at the steel industry, the aluminum industry, some of these processes were developed 100 years ago and have not really, changed that much, right? So these are well understood, well optimized processes. And so the only way that these folks are going to get, single digit and even double digit % improvements in these processes is to adopt AI. To me, that's really the next step. And when we look at, I'm sure you've probably heard a lot that we are in the fourth industrial revolution, right? And so when you look at that, when we look at all of the other industrial revolutions, you don't know until you look backwards, what was that revolution all about? I really firmly believe that at the end of this fourth industrial revolution, we're going to look back and realize it was about getting to AI. So like I mentioned, I've been at this for 24 years. So if I go back to the early years of my career, we were doing a lot to just collect data. So we were implementing time series databases, which in our world are called historians. We were implementing these historians on the plant floor to collect all that data. And a lot of people were saying, okay, we're going to collect all this data, but what are we going to do with it? Well, now we know why we were collecting all this data for all that time. We were collecting it to be able to feed these industrial AI algorithms.
And you mentioned there that we're not at mainstream adoption levels yet in the world of manufacturing. So what would you say the current state of AI adoption in the industry is, and how is the sector experiencing this gradual shift towards AI?
Well, and every company is experiencing it a little differently, right? So you've got those companies that are very forward thinking. Now, those tend to be the companies that have always kind of focused on continuous improvement and have always had continuous improvement dollars available. And so those companies tend to be the ones who are the most forward thinking, and they may already have, I'll go in there and they may already have a data science team or something like that we'll work alongside of. And then you've got companies, I've got a steel customer right now where the CEO has said, nope, no AI. We're not doing it. That's not going to happen here, right? So, okay, I mean, that's fine, I guess. But what we're doing then is we're doing a lot of data readiness with those type of customers. And what's interesting is that, that particular company, that steel company, has thousands of employees around the world. Most of those employees work at a site and they are interested in getting to an AI future. And so in some ways, they kind of know that it's just a matter of waiting out the CEO. And so we're doing projects so that when, maybe new leadership is in there that's a little more forward thinking, they're ready to start to move on that. And so it's the whole spectrum of all of those different types of things. I think that a big challenge, though, and so you mentioned, I'm out in Wyoming this week doing a digital transformation workshop for some mining customers. And I think one of the things, that I'll spend a lot of time on today with them is the education aspect of it, because most of these customers don't even really know what the state of the art is. What is industrial AI capable of today? And it's funny because they oftentimes either way underestimate what we can do with AI or way overestimate what we can do with AI. They either think it's not much different than some of the other technologies that we've already had, and to some extent, but it does go further than that. Or they think we're at the Skynet level, and I'm like, okay, well, no, we're definitely not there yet. So part of it is just the education aspect of it to get them to understand. And then once I can get them understanding what the state of the art is and what it's capable of, now I can start to get them thinking about how we can apply that to the specific problems, in their industry.
And they do say we often overestimate what we can achieve in that short term, but often underestimate what we can achieve in the long term there. And I'm curious,
right.
What would you say are the various types of AI being utilized in manufacturing sector? Because as you said, there's so many different areas and there's no such thing as a one size fits all. So what are you seeing there? What different types of AI are being used in the sector?
Yeah. So generally, when I talk about this, there's three primary categories of AI or machine learning, really, because machine learning is what underlies all this. There's three primary categories of machine learning that we can put all of industrial AI that is in use today in manufacturing. We can put into those three buckets. Then there's a fourth, but that we'll talk about here in a second. The three are the first category is what's called unsupervised learning. And so that is in our world, in the industrial world, we typically describe that as anomaly detection. And so what that is you can hook up a model to the process. It does not require any previous training. It doesn't require any a priori knowledge. You just hook it up. It starts to monitor the process, and it can tell you when things start to go awry. Now, importantly, it cannot tell you why things are going weird. All it can say is, look, I've been watching this process for the last week. I've got a pretty good feel for what normal looks like, and I can tell you right now things are starting to go abnormal, okay? That's unsupervised learning. The second category is what's called supervised learning, and that encompasses most of what we think of in terms of machine learning today. And that's where you take large volumes of very clean, very correlated data, and you send it into the ML model, and you are trying to train it to be able to predict a single value. And that's all it can ever do, is predict a single value. So anytime you hear anything described as predictive maintenance, predictive quality, that's supervised learning. We're going to take large volumes of data. We're going to train it to predict a value. That value could be, in the case of predictive maintenance, how many days until this piece of equipment is going to go down? In the case of predictive quality, what's the final quality of this batch going to be before I even finish the batch? Predict for me what the final quality of this batch is going to be. Now, there's an important assumption built into supervised learning, and that's that somebody knows what to do with that prediction, right? So somebody can take action based on that prediction to fix things. So in the case of predictive maintenance, if I can predict for you how many days until this piece of equipment is going to go down, does somebody know what to do to fix that with that information? If I can predict for you what the final quality of this batch is going to be, does somebody, an operator, a supervisor, do they know how to fix that batch then to get it back on spec? Let's say I predict that it's going to go out of spec, that batch, we're going to have to derate it, or it's not going to be a good batch. Does somebody know how to fix that problem? So that's kind of an assumption built into supervised learning. The third type, and this is the type that is unique to RoviSys, there's only a handful of system integrators in the world who can do this, is called autonomous AI. And this is where we actually train a neural network, and it does what, frankly, a lot of people think AI can do, and that's that it takes an action. So it actually knows what's the next best action to take. And it can tell you. So it can look at the state of the system, and it can say, based on everything I'm seeing, here's your next best move. And that's very unique in this space. It's relatively new, but not that new. We've got customers running it in production today. And typically that autonomous AI is deployed in what's called decision support mode first. So that's where it's making a recommendation, but a human operator is taking that action based on its recommendation. Now, you can take it from there and put it into what's called direct control. That's where it's actually sending that set point down to the control system itself without a human in the loop. But we always start with decision support because we want to make sure that all the humans involved trust that it's making the right decisions. Those are the three big categories of industrial AI today. The fourth category and what's coming is generative AI. And we can talk a little bit more about that if you'd like to, but that's the stuff that's coming, but is not quite there yet for the manufacturing world.
And when we've got all these different categories, how do you distinguish between AI for production processes and AI for other parts of the business?
Yeah. So typically the way I look at it is, a manufacturing and industrial customer, they have kind of, when we look at the problems you're trying to solve, there's two kind of big categories of problems, what I would call operational problems and knowledge problems. So on the plant floor, we're primarily interested in operational problems and solving those types of operational problems. And we can do that with any of the three types of AI that I talked about. We can solve those operational problems. So generative AI, and when I say that for your listeners, that's the ChatGPT. Those are the large language models, the LLMs. That's that whole category of AI is called generative AI. That is really what I am looking for in the future to solve the knowledge types of problems that you find at these companies. Those are really how I kind of split those two. And in the manufacturing world, like I said, I don't feel like we're ready to start to adopt the generative AI yet.
And for any business leaders listening in the world of manufacturing, they're hearing about artificial intelligence in just about everything. They know they need to be doing something, but where should manufacturing companies be looking for those ideal places to begin that journey and start adopting AI? They don't want to just shoot for the moon straight away. Where should they begin?
Right. Yeah, it's a good question. I think that where we typically, particularly around autonomous AI, because of its ability to make human-like decisions and actually build long-term strategy and then follow that strategy over time, we are really recommending to customers that they look at where they have places in the process right now that are too complicated for traditional control systems or traditional optimization techniques. And so they've had to add humans into the mix. Those are the types of places. There's a human in the loop, in the decision-making loop. Those are great places to look to adopt autonomous AI. So for instance, if you've got, and I mean, it can be anything from, hey, this part of the process is so finicky and it's so difficult to control that we always have to have a human there. That's a great place to look at training autonomous AI to be able to do that. Or if even at things as varied as like scheduling problems, this part of the process, we always have to have a human production scheduler because it's too complicated. We can actually train autonomous AI to be able to take the place of that human scheduler, or at least augment maybe a less experienced human scheduler in that process. The other place that we oftentimes will look at adopting AI is in what's called unknown starting and unknown system conditions. So unknown starting conditions are things like, so for instance, Microsoft has a use case that they used autonomous AI, and it's public, so I can talk about it. They trained it for PepsiCo to make Cheetos, and the moisture content of the corn when you're making Cheetos can vary significantly. And so what they do is they just start popping Cheetos. And then they've got experienced operators that will sit there and they'll make adjustments to the knobs until they're making good Cheetos. But then as, they dump the next batch of corn in, and the moisture content can be different. And so then they maybe start making out of spec Cheetos. And so then the operators have to make adjustments and get back to making good product. That's unknown starting conditions. We can train an autonomous AI. We call it a brain. A neural network trained this way is a brain. We can train an autonomous AI brain to actually be able to get to making good product faster, even in the face of unknown starting conditions. The other one is unknown system conditions. So this happens in processes like polymer reactors, where you have to have a highly trained, typically 7 to 10 year expert operator, because you can't measure exactly what's going on in the reaction directly. So you have to use what are called proxy measures. So you have to have a really experienced operator that has built a mental model of what's going on in that reactor and can read the proxy measures and be able to react to them to control that reaction. We can train an autonomous AI brain to be able to read those proxy measures like a human can and be able to control it at least as well as an expert operator. So all of those are great places to look for adopting AI, particularly if you're trying to make, $1 million a year plus ROI types of improvements. Those are great places to look.
And again, for that same business leader in manufacturing who could be listening to our conversation today, anywhere in the world, are there any stories that you might be able to share about somebody that's been on this road already? They've got that AI success under their belt. You must hear a lot of these. So is there any you are able to share today?
Oh, for sure. I've got a couple. The one is that I'll lead off with is, so this was a glass bottle manufacturer, And they had developed a brand new way of creating glass bottles. And again, this is a process that has not changed a lot in 100 years. And they've created a brand new way of making it, and it will be cheaper. It will use a significantly less amount of energy. The footprint of these glass bottle facilities is going to be significantly smaller. So in every regard, this is an improvement. However, there was a problem, and that was that the process was very finicky. So you had to have an expert operator who could really get dialed in, and then you'd be making good bottles. But then over time, it would start to drift, and you'd be making out of spec bottles. And if that expert operator can't be there 24/7 standing at the controls, making adjustments, if they go to lunch for an hour and they come back, you're making bad bottles. So that was a big problem. Well, so we actually built an autonomous AI brain that could control that process as well as their expert operators. And it's in production today. And once this company gets to the point where they start, right now they're just making bottles for themselves, but the long-term goal is to actually market this and sell this as basically a glass bottle in a facility that you could buy, and a bottle manufacturing facility you could buy, and every one of those will ship with this autonomous AI brain to be able to control this process better. Another example is so this was a sausage manufacturer. And one of the challenges they have is, of course, sausage is a natural product. And so the amount of moisture in that meat coming in is going to vary. And they had real issues with controlling that moisture to the point where they would go and they would smoke those sausages, and it could smoke for anywhere from 6 hours to 14 hours, trying to get down to the moisture content that they need. That's a big swing, and that has significant impact on things like they don't run 24/7. So, you could run into a situation where that shift has to leave, and so you've got to kind of leave it for overnight. I mean, there's a lot of issues with having that kind of variability. We actually don't see that type of variability very often in our world, 4 hours versus, or 6 hours versus 14 hours, those types of swings. And so what we were able to do is we were able to build an autonomous AI brain that actually monitors, I call it a moisture czar. It monitors everywhere in the line where we're adding moisture to that, and dials in very specifically dials in at all those places to try to make sure that we're not adding more moisture than is absolutely necessary based on the amount of moisture that came in through the meat product. Now, again, that's something where a human could have done that, but there's no human whose job it is to be the moisture czar. We built a brain to basically be able to do that. And so, I mean, that's just two. We've got lots and lots of success stories that we can talk about. But in a lot of ways, what I like to say is that we're really solving the unsolvable problems. We're solving problems that have never been attempted by any of these companies to try to solve before.
And there are two big trends at the moment, I think, if you look at every business. One is AI that we've talked about today, and the other is sustainability and the responsibilities around that. We're seeing things like ESG scores, etc. But, of course, AI does have a well-documented energy problem. So how does sustainability and AI go together? How do you see this relationship evolving, or are there any synergies there?
I think there are. I think that when you look at sustainability, most of these projects, if not all of these projects that we talk about trying to solve with AI, end up having an impact on sustainability. When you're, that glass bottle manufacturer, right? So if I can get dialed in with AI and they can make better on-spec bottles, and so because all the off-spec bottles that they make, all of that gets remelted. All of that is energy lost. All of that is energy wasted, right? So if I can get to making on-spec bottles faster and sustain that on-spec bottles, now I'm not wasting all that energy on remelting that glass. We had another project where a customer makes flat glass, and so you cut out different window shapes out of this flat glass. And one of the challenges is that the glass may have minor defects, it may have inclusions, and you have to basically plan the cuts around those inclusions so that they don't end up in the customer's window. And they had built a very rudimentary optimization algorithm to lay out how to cut the glass. Well, we built an AI optimized algorithm so that we could vary as close as possible. We could squeeze as many window cuts out of that sheet of glass as possible while still missing any of the inclusions and things like that in the glass. I mean, they were saying that they were telling us anecdotally that we probably saved them hundreds of thousands of dollars a week in energy costs in terms of not having to remelt all of that extra glass. And that's great in terms of the bottom line. But when you look at it from a sustainability standpoint, that's a significant improvement in the amount of energy wasted in the past versus adopting AI. So I think that one of the things that folks on the plant floor we oftentimes don't think, because I work with these folks, one-on-one, and they don't think in terms of sustainability. They think in terms of, energy costs, and they think in terms of reducing waste, and they think in terms of increasing throughput. But all of those things have a significant and material impact on the sustainability of that company. And so I think sometimes it's just a matter of kind of connecting those two worlds and realizing, that we're making major improvements to sustainability through this adoption of AI.
And at the end of every podcast, I always try and leave some actionable insights and tips. So for anybody listening today, maybe we've set off a few of those light bulb moments. What steps can manufacturers take to ready themselves for AI-driven changes? Any tips or advice there?
Yeah, I mean, so this is typically how I wrap up my presentations, right? So today, when I talk to these mining customers, I'm going to talk to them about, even if your company is not ready to jump, into AI with both feet, there are things that you can do today. So look at your infrastructure. We are doing more infrastructure upgrade projects now, RoviSys, than we've ever done in our history, because folks are recognizing that to get to an AI future, they're going to have to make those investments. So look at your infrastructure. Are there places where we need to improve networking? Are there places that we need to improve data collection? Then look at your OT data strategy, your operational technology data strategy, and look at all the places where you have gaps in your data collection. And what can we do to improve that? Then don't look at just one line or one site. Now look enterprise-wide, and let's see what we can do to collect all that data, correlate that data across all of those different sites, and build an enterprise data warehouse that includes the plant floor data, the OT data. All of this, I haven't even talked about AI yet, right? All of those are projects that you could tackle today, even if your organization's not ready to take on AI. And all of that will make you ready when it's finally time to start to dip your toe into that AI, and start to take those first steps towards that AI journey. What I typically say, though, in terms of a call to action is just don't wait, right? Because here's the problem. That steel manufacturer that I talked about, while they're not taking on any AI projects right now, their peers are. And I know that because I'm working with them. So while you may not be ready, there's other people in your industry who are taking those first steps. So don't wait. Take those first steps. You don't have to swallow the elephant in one gulp. You can walk before you run. And the other thing that I always say, and I know this sounds self-serving, but I always say find an OT system integrator that you can trust, who can help you navigate all the hype. There's a lot of hype in this space. There's a lot of vendors that are selling, frankly, kind of snake oil. And so it helps to have an OT system integrator that you can trust, who can help you. We're independent. We don't have any skin in the game. I don't care what vendor you end up choosing. All I want to make sure is that you've got an AI solution that's going to solve the problem for you. So even if it's not RoviSys, find an OT system integrator that you can trust. I think it's that important when you're taking these steps on this journey.
Fantastic. So many great insights there, and I cannot thank you enough for coming on and sharing those with everyone listening around the world. And before I let you go, I'm going to ask you to leave one final gift for everyone, and that is a book that means something to you or that you'd recommend that I can add to our Amazon wish list and the books can and the listeners can check out. But what would you like to leave everyone listening with, and why?
Yeah, I mean, I would say right now, probably my favorite book that I've read in at least the last 10 years was a book by Andy Weir. So if you have heard of the book called The Martian, and then there was a movie, The Martian, his newest book is called Project Hail Mary. If you liked The Martian, I loved this book even more. And if you happen to have Audible, I don't want to give away too much, but the Audible production in particular, based on some of the things that happen in the story, the Audible production is perfect for that. I think that's the best way until they make a movie, which supposedly they're going to. But I think it's the best way to consume that book. Project Hail Mary, definitely recommend that.
And this podcast has just cost me one Audible credit, so thank you for that. I will be using that. And for anyone listening wanting to find out more information about RoviSys, all the work that you're doing, how you can help anybody listening, where would you like to point everyone?
Yeah, so if you just go to RoviSys.com, so that's ROV as in Victor, ISYS.com /AI, that'll get you to our industrial AI section of our website, or you can always look me up on LinkedIn. My name is Bryan, Bryan DeBois, DeBois. So if you just search for that on LinkedIn, you'll find me there, and I'm always happy to connect with anyone there.
Well, again, a real pleasure to have you join me today and providing that vision for a future of manufacturing that is dominated by AI and how the market is evolving, how industry leaders should adapt, and also how to start a digital transformation journey for any medium to large size manufacturing company and ultimately unlock those new possibilities with digital innovation in manufacturing. Pure pleasure from my side, but thank you for sharing your story with me today.
Thanks, Neil. Appreciate it.
Wow, what an enlightening discussion on the future of manufacturing and indeed the role of AI in driving that transformation. And as Bryan shed light on various aspects of industrial AI, from anomaly detection to autonomous decision making, and highlighting the importance of investing in data infrastructure, partnering with trusted integrators, there is so much valuable advice in that. So as we conclude, I think it's clear that the path to digital innovation holds immense potential for enhancing sustainability and efficiency in every manufacturing process. But hey, I'd love to hear your thoughts on the ideas Bryan shared today, and how do you envision the future of manufacturing, and what steps are you considering to adapt to these changes? Well, let's continue this conversation. Share your insights and questions with me by emailing me, techblogwriter@outlook.com, Twitter, LinkedIn, Instagram, just @NeilCHughes. But until next time, keep innovating, keep pushing the boundaries of what's possible in manufacturing, and I'll be back again, same time, same place tomorrow morning. Speak to you all then.